So here are the notes on solving a quadratic equations or solving quadratic equations for Math 023. This is Module 2. And a quadratic equation is any equation in the form of ax squared plus bx plus c. And we can find the solutions to these equations by three ways, or we're going to investigate these three ways. One is by factoring, one is by the quadratic formula, and then also analyzing the graph. When we use graphing to solve it, we'll look at the graph to see where a graph crosses over the x-axis. When we use factoring to solve it, we'll look at the zero factor theorem, which means we'll take our quadratic formula and set each factor to 0 and then solve those equations. And then we'll also look at the quadratic formula to solve it. And when we look at the quadratic formula, we will simplify our expression down until we can't simplify it anymore to get the solutions. So when we solve a quadratic, the first thing we want to do to solve any quadratic is make sure your quadratic equation, which is an equation that is in the x squared form, is equal to 0. So you want to get all the terms to one side and make it equal to 0. If you look at our first problem here, it's already equal to 0, so we don't have to solve or move anything to one side. We have it equal to 0. This one we're going to solve by factoring. So what we're going to do is make sure our terms are written in descending order, which we have x squared and then x. So you want to count down with your exponents from the highest to the lowest. And we're going to factor it. So I can see here that we have a greatest common factor of x. So I'm going to factor out an x. And when I do that, I'm going to be left with x plus 9 equals 0. And I can't factor it anymore. So now to solve it, I'm going to take each factor. Remember, factors are what you multiply together, and set them equal to 0. So we're going to take our first factor of x and x plus 9, because those are what we're multiplying together, and make them equal to 0. So we'll have x equals 0 and x plus 9 equals 0. Now the first one, right here, this is already done because x equals 0. We can't do anything else with it. But the second one, we have to solve the equation and get this x by itself. So they added 9. To solve it, we are going to subtract 9 from both sides. And when we do that, my 9's over here will cancel, and we get x equals -9. So the solution set for my equation, the two solutions, are x equals 0 and -9. And to show that it's not an ordered pair, we want to write it as a solution to a set. We're going to use our brackets around the set, not parentheses, but the brackets. All right, next, we are going to solve 2a squared plus 12a minus 1 equals 4 plus 3a. And for this one, again, we have, it's not equal to 0, so we have to move the 4 and the 3a over to the other side. So I'm going to start just by subtracting 4 from both sides. Okay, and that's going to leave me with 2a squared plus 12a. -1 minus 4 will be a -5, so minus 5 or equals, and then it equals 3a. Okay, now again, we still want it equal to 0, so I'm going to subtract 3a from both sides. And that will give me 2a squared plus 9a minus 5 equals 0. Now what we can do is we can go ahead and factor. There is not a greatest common factor that I can pull out, so I'm going to factor it because it's a hard trinomial by the box method. Draw my box. So I'll put my 2a squared in there and my 5 there. Remember, our middle term has an a and we need our number. Now, remember, to get the numbers up here, we have a plus and a minus. So we're going to have one of each sign. So I'm going to put a plus and a minus there. And then a times c is 2 times 5, or 10. So if I look at my factors of 10, we have 1 and 10 and 2 and 5. And I need a middle term of 9. So we're going to use the 1 and 10 to help us out. We need a positive 9, so I'm going to make the 10 my positive, and that'll go there, and my 9, or my 1 will be negative, so that'll go right there. Now what we're going to do is factor, and we'll go straight up first. So 2a squared and 1a, my GCF will be a. 10a and 5, it's only going to be 5 because I don't have an a with both. Now we're going to factor left and right. 2a squared and 10a will be 2a. And 1a and 5 will be 1. So my factored form of the equation is going to be a plus 5 times 2a minus 1. And then it's still equal to 0. And now what we're going to do is take both factors, so the a plus 5 and the 2a minus 1, set it equal to 0 and solve the equations. We have a plus 5 equals 0 and 2a minus 1 equals 0. We'll subtract 5 from both sides, so I get a equals negative 5. And here we'll add 1 to both sides. So we get 2a equals 1. Divide by 2, so a equals 1/2. And then the last thing we want to do, I'll do right over here, we have to write our answer as a solution set. So we'll say that a is equal to, and then put our brackets, and we have negative 5 and 1/2. And that's our final answer. So here we're going to look at example C. And this one's nice because it is already factored for us. It's equal to 0 and it's factored. So I'm just going to take the two factors, the x plus 6, and make it equal to 0. And then the x minus 11 and make it equal to 0 as well. And solve the equation. So I'll subtract 6 from both sides here. And I get x equals negative 6. And here I will add 11 to both sides. So I get x equals 11. And that is my solution set. So I'll put my brackets and negative 6, comma 11. Okay. D, again, it is nice as well because it's already factored and it's equal to 0. So we don't have to do anything other than take our two factors, our 3x minus 2, and make it equal to 0. And our 5x plus 1, make it equal to 0. So we will add 2 to both sides, and we get 3x equals 2, divide by 3, so x equals 2/3. And then also for the next one, subtract 1 from both sides, and we get 5x equals negative 1, divide by 5, so x equals negative 1/5. And then we just write it as a set. So we'll put our brackets, and we have 2/3 and negative 1/5. And that's it for those two. All right, now example E. This one, it's already equal to 0, so we don't have to worry about that, but we do need to factor the expression. So what I'm going to do is first start, and I don't believe there's a greatest common factor, but I do have two terms and subtraction here, and they're both perfect squares, so I can factor it as your difference of perfect squares. So it's going to become 3b minus 7 times 3b plus 7 equals 0. And now again, you take each factor, so 3b minus 7, and make that equal to 0. And 3b plus 7 equal to 0, and then go from there to solve. So we'll do plus 7. So we have 3b equals 7. Divide by 3. So b equals 7/3. And then here we'll subtract 7 from both sides. So 3b equals negative 7, divide by 3, and b equals negative 7/3. So again, just write it as a solution set. So we have 7/3 and negative 7/3. And that one's done. Now, if you look at F, it is not solved to equal 0 yet. So what we need to do is we want to make it equal to 0. And this is our highest degree, and it's a negative. We really want to turn it into a positive. And we want to put it on the other side. So it's a negative 2p cubed. We're going to add 2p cubed to both sides. So that is going to leave me with, and I'm going to put it in descending order. So I'm going to have 2p cubed minus 30p squared plus 108p, and that will be equal to 0. And I did reverse the sides there just because that's how we're used to seeing it. Now, I do have a greatest common factor that I can factor out, and that would be 2p. So if I divide everything by 2p, 2p cubed divided by 2p will give me p squared minus 15p plus 54. And that equals 0. Now, my trinomial here in the middle, I can factor this further. So I'm going to keep my 2p, but I'm going to factor my trinomial. Because it's a minus and a plus in that order, we're going to have two minus signs. So we'll have p minus, it's going to equal 0. We need 54 that adds to 15. And 54, I know that it is, we can do 6 and 9. And those will add to 15 as well. So now what I want to do is take each term or each factor and set it equal to 0. I'm going to do 2p equals 0. I'm going to do p minus 6 equals 0. And p minus 9 equals 0. Divide by 2 for the first one. Anything, or 0 divided by anything is 0. So we get p equals 0. This one I have to add 6 to it. So now I have p equals 6. And here p minus 9 equals 0. I'm going to add 9 to both sides. And that will leave me with p equals 9. So again, write it as a solution set. We get 0, 6, and 9. And you may say, well, all the other ones we've had 2 answers, and that is correct. But the degree of the equation will tell you how many answers you have. And if you recall from 022 or a previous course, the degree is the highest power represented in one of your terms. And here it's 3. A degree of 3, an equation with a degree of 3 will cross over the x-axis 3 times. So that's why we have 3 solutions. All right, now to solve G, again, you always want to check to see if it's equal to 0. And in this case, it is not already equal to 0. So what we have to do is make it equal to 0 by subtracting 20q from both sides to make it equal to 0. And when we do that, that will equal 0 there. So we'll have 0 equals, and it's going to be 2q to the third plus 6q squared minus 20q. That's a little messy. But now I do have a greatest common factor of 2q. So I'm going to pull out my 2q, which will leave me with q squared plus 3q minus 10 equals 0. And then again, my trinomial, I can factor that. So I'll keep my 2q. And I have a plus and a minus in that order. So that means I'll have 1 plus and 1 minus as I factor. And I'll put my q's there. So we need 10. We need to multiply to 10 and add to get 3. So 2 and 5 would work for 10. And I need a positive 3, so it's going to be a positive 5 and a negative 2. And it equals 0. And now again, I'm going to take all my factors, set them equal to 0. So I have 2q equals 0. Q plus 5 equals 0. And q minus 2 equals 0. I'll divide by 2 here. Again, anything, 0 divided by anything gives us 0. So q equals 0. I'll subtract 5 from both sides. So I get q equals negative 5 for the second equation. And here I will add 2 to both sides. So I get q equals 2. And my solution set will be 0, negative 5, and 2. Now we have our last example for solving with factoring. And here it's like, oh, you look at it and you're like, oh, this is great because it's already factored. But it doesn't equal 0, it equals 3. So what we have to do is move that 3 to the other side by subtracting it from both sides. And now I have c times 4c minus 11 minus 3 equals 0. And we can't leave it in this form. We have to incorporate that 3. So what we have to do is distribute the c. And it gives us 4c squared minus 11c minus 3. So now we have our trinomial. We need to factor it. This is one where we can use the box because it's a hard trinomial. So we'll put our 4c squared here and our 3 here. Because it's a plus, or it's a minus and a minus, that means we're going to have 1 plus and 1 minus. And 4 times 3 is 12, and I need a middle term of 11. So we could do 4 and 3, 2 and 6, or 1 and 12. And I need to get a negative 11. So that means my 12 will be negative, and my 1c will be positive. And then again, factor across and up. I'll do across first, so that's going to give me c there and 3 there. And then when I factor up, I'm going to get 4c and 1. So when I factor, it leaves me with 4c plus 1 times c minus 3 equals 0. And then we'll set each factor to 0 and solve. So we'll subtract 1 from both sides. So I get 4c equals negative 1. Divide by 4. So c equals negative 1/4. And then we'll add 3 to both sides. So c equals 3. And that gives me a solution set of negative 1/4 and 3. Our second way to solve a quadratic equation, or to solve a quadratic and find the solutions, is to use our quadratic formula. This is a formula. I do want you guys to know and memorize, know how to use it. The nice thing about the quadratic formula is you don't have to factor to do it. You just need to know the numbers in the trinomial. So the quadratic formula is x equals the opposite of b, so negative b, or the opposite of b, plus or minus the square root of b squared minus 4 times a times c, and all of that is divided by 2a. Now, the a, b, and c, you might ask, where do we get that from? It comes from your quadratic equation. Remember, the a comes from the x squared term, the b comes from the x term, and the c from the constant term. So let's try it out with example a here. Now, I don't have an a officially, but remember, if you don't see anything, it's that 1. So when I plug it into the formula, and I'm probably going to need the whole bottom here, but we're going to do x equals the opposite of b. So my a is my 1, b is negative 13, because you keep the sign with it, and c is 36. So the opposite of negative 13 will be positive 13. Then we'll do plus or minus the square root of, and we're going to do b squared. So negative 13 squared will give me 169, because 13 times 13 is 169, minus 4 times 1 times 36. And that's going to be all over 2 times 1. So now we got to go about simplifying it. So we're going to have 13 plus or minus, and then underneath the radical, I'm going to have 169 minus 4 times 36 is going to give me, let me find out real quick. $144. And that's all over 2a, or 2 times 1, which is 2. And then I'm going to move up here, and we'll do b on the side. So now I have x equals 13 plus or minus 169 minus 144 is going to give me 25. And it's still under the radical because I haven't taken the square root. But now I can. So it will be 13 plus or minus 5 divided by 2. Which, when I do the math here, it's going to give me x equals 13 plus 5 divided by 2, which is equal to 18 divided by 2, or 9. And then I'll also do x equals 13 minus 5 divided by 2, which will give me 13 minus 5 is going to give me 8. And then divided by 2 will give me 4. So my two solutions, I'm going to put them up here because I'm running out of space. X equals 9 and 4, and we'll put our brackets around that. All right, now B. I'm going to draw a little line here and maybe go to red so it's a little easier. Okay, so B, remember it has to equal 0, just like any other one. This one doesn't. So first thing I'm going to do is I'm going to put it up top here so we can see it, is subtract 9 from both sides. So it's going to leave me with 3x squared. Oh, hold on one second. I'm going to erase that. It was a little high. Okay. So we have 3x squared minus 6x minus 9 equals 0. So again, here's my A, my B, and my C. So we're going to start off with the opposite of B. B is negative 6, so we're going to have positive 6, plus or minus B squared, so 6 squared is 36, or negative 6 squared, minus 4 times A, or 3, times C, which is a negative 9, all over 2a, or 2 times 3. So now I need to simplify, and I'm going to get x equals 6 plus or minus, and then it's going to be 36, and negative 4 times 3 is 12, and then 12 times 9 is 108, and we have a negative 12 times a negative 9, so it gives me a positive 108, because those two negatives right here, and here make it a positive. And then all over 6. So now I'm going to have x equals 6 plus or minus 36 plus 108 gives me 144 over 6, which is going to give me 6 plus or minus the square root of 144 is 12 over 6. So when I break it down, we'll have 6 plus 12 divided by 6, which gives me 18 divided by 6, which equals 3. Or we'll have 6 minus 12 divided by 6, which gives me a negative 6 over 6. And that equals a negative 1. So my solution set, if I can fit it in here, is 3, negative 1. So we're going to continue solving through our quadratic formula. And again, just like when we factor, you have to make sure your equation is equal to 0 to start with. So the first thing we're going to do for C is subtract 14x from both sides to make our equation equal to 0. So that's going to give me 5x squared minus 14x minus 3, because I want to write it in descending order. So it's easy to identify my A, my B, and my C. So again, here's my A, my B, and my C. When I plug it into my formula, it's going to be x equals, remember, it is the opposite of B. My B is a negative 14, so I'm going to put a positive 14 there, plus or minus the square root of B squared. So if we square 14, or negative 14, you get 196, minus 4 times A, which is 5, and then times C, which is a negative 3, all over 2 times 5, or 2 times A. So when we go to simplify, we're going to have x equals 14 plus or minus, and let's see, we're going to get 196 plus, because negative 4 times 5 is 20, negative 20, but times a negative 3, those two negatives give me a positive 60. So I'll put my plus 60 there, all over 10. So we'll have x equals 14 plus or minus the square root of 196 plus 60 equals 256 over 10. And we get x equals 14 plus or minus the square root of 256 is 16, and it's all over 10. So when I do the two problems, we're going to have 14 plus 16 divided by 10, which is going to give me 30 divided by 10, which equals 3. Or we'll have 14 minus 16 over 10. So it's going to be negative 2 divided by 10, which would give me negative 1/5. And we're going to leave it as a fraction. We don't have to turn it into a decimal. And those are my two answers. I can put them in to solution set 3, negative 1/5. There we go. All right, now D is similar to the one we just did with factoring, the last one we did, where it looks nice because it looks like it's factored, but we're using our quadratic formula, so we don't need it in factored form. And it's not equal to 0. So I'm going to start off and just subtract 14 from both sides. And I will get D times 3D minus 1. Oops, and then I need to erase that. Minus 14 equals 0. So what I want to do first is distribute my D. So I get 3D squared minus 1D, or minus D minus 14 equals 0. Okay, now I have my A my B, and my C. Now my B is not D, but it's actually that -1 there. So when I go to do this, I will have, instead of x equals, it's going to be D equals, because that's our variable. All right, the opposite of B. If B is -1, we're going to use 1 plus or minus, and then the square root of B squared, -1 squared is 1, minus 4 times 3 times -14, all divided by 2 times A, or 3. So then we have D equals 1 plus or minus the square root of 1. And then again, 2 negatives here make it plus. And 4 times 3 is 12. 12 times negative, or -12 times -14 gives me 168 all over 6. So now I have D equals 1 plus or minus the square root of 169, because I'll add 1 plus 168 over 6. So I get D equals 1 plus or minus the square root of, or not the square root of, excuse me. The square root of 169 is 13 divided by 6. So we'll do 1 plus 13 divided by 6, which gives me 14 divided by 6, which equals 7/3 when we simplify it as a fraction. And then we have 1 minus 13 divided by 6, which gives me -12 divided by 6. So we get -2 with our final answer. So when we write it as a solution set, it will be D equals 7/3 and -2. Okay, so here's our last example with using the quadratic formula. And if you look at this one, you're like, whoa, this is crazy. There are fractions. I don't want to deal with fractions, even if we're using the quadratic formula. And I agree with you. So what we're going to do is we're going to think back to 022 when we cleared our equation of fractions. So remember, what we're going to do is we're going to multiply by a common denominator. Since my two denominators are 3 and 6, my common denominator is 6. So it's like multiplying everything by 6 over 1. And if I do the work over here on the side, if I do 2/3 times 6 over 1, it's going to give me 12 over 3, which equals 4. So I have, and I'll write it over here, we're going to have 4w squared. I'll keep my minus sign. Now we're going to do 20 over 3 times 6 over 1, which gives me 120 over 3, which if I simplify that and divide by 3, we get 40w. And then equals, and we'll move it over in a second, so I'm just going to clear it first, and then we'll make it equal to 0. So it's a -100 over 6. If I times that by 6 over 1, you get -600 over 6, which gives me -100. We have -100 here. But I need to make it equal to 0, so I'm going to add 100 to both sides. And we're going to have 4w squared minus 40w plus 100 equals 0. And we can plug this into our quadratic formula. So we are going to do, b is -40, so we will say that w is equal to 40 plus or minus, and then it's going to be 40 squared, which is 1600, minus 4 times 4 times 100, all over 2 times 4, because 2 times a. So we'll have W equals 40 plus or minus, we'll get 1600 minus, and we'll do 4 times 4 is 16. 16 times 100 will give me 1600 over 8. So we're going to have W equals 40 plus or minus 1600 divided by, or minus 1600 is 0. The square root of 0 over 8. The square root of 0 is 0. So we'll have 40 plus or minus 0 equals 8. Now in this case, if I do 40 plus 0, I get 40. If I do 40 minus 0, I get 40 as well. So this one, I have two solutions, but they're exactly the same. And it'll be 40 divided by 8, which gives me 5. And that is my solution set. So I'll say W is equal to 5. And you can still put it in the brackets. So the next way we're going to solve a quadratic is through graphing. And for this, you're going to need to use your graphing calculator. And what I'm going to do is I'm going to solve them here on the notes first by showing you the graph. And then what we're going to do is I will post an additional video with me showing you how to use the graphing calculator to do this. Again, when you graph a quadratic, it's going to form a U shape or a parabola shape. So it can either open up or sideways. But the solutions to the equation are where the graph crosses over the x-axis, because we want to find out what x equals. So you're going to find out where it crosses the x-axis. You again want it to make it equal to 0, or because we're going to put it into the calculator, y equals is the same thing. And then we're going to go ahead and type it. I'm going to type it into my calculator. I went to y equals, and I typed in 2x squared minus 8. And you want to graph it on your standard window, which if you're not sure what the standard window is, you can, if it's a Texas Instruments graphing calculator, do Zoom 6 and it'll give you the standard window. All right, so when I graphed it, my graph looks like this. It looks about, and again, I'm kind of sketching it here. It's not going to be perfect, but it looks similar to that. But what we want to look at is where the graph crosses over the x-axis, and where it crosses over that x-axis is going to be our solution. So it crosses over, I'm going to put it as a solution set, at -2 and +2. So those are the solution to my quadratic. Now again, because we're looking at a graph, it's always approximate. It's not as exact. For ours, they work out pretty nicely, so it's not going to be too hard to find the answer. But when you look at the solutions by graphing, it's always approximate and not exact, unlike when we do factoring in the quadratic formula. So our second one, it's already equal to 0. Let's go ahead and type it into our calculator. So we'll do y equals, again, x squared minus 3x. And I'll graph it again on my standard window. Okay, and then I'm going to sketch it on here. And bear with me. Okay, so there's our parabola this time. And again, we want to find out where it crosses over the x-axis. So it crosses here and here. So x is approximately 0 and 3. Now for C, again, remember you want to make it equal to 0. So the first thing we're going to do is move that over to the other side. So I'll rewrite it down here. So it equals a -2, so that means we're going to add 2 to both sides. We're going to have 2x squared plus x plus 2 equals 0. And that means then we're going to enter it into our calculator. So I'll go back to y equals. And if you don't have a graphing calculator, there are online graphing calculators. And you just Google online graphing calculators. You can use that for your notes and the quiz. But when you take your test in the test center, you will need a graphing calculator. You can borrow them from the library for like 4 hours if you go to the circulation desk with your library card. And you can take it to the test center then. Okay, so I typed it into my calculator, and when I graph it, it looks similar to this. Actually, let me erase that. I think it goes down a little bit further than that. There, it's kind of like that. Now, but if you look at this, our solutions are where it crosses over the x-axis. Does this equation cross over the x-axis? No. So what we would say for this one is there is no real solution. There would be a solution, but it's not going to be real numbers. So it's no real solution here. It doesn't cross over the x-axis. And that's it for that one. So now our last one that we're going to do, again, I want to make it equal to 0. So I'll take our x squared minus the 4x equals 32. Subtract 32 from both sides. And you get x squared minus 4x minus 32 equals 0. And we'll go ahead and graph it. So go back to y equals. We have x squared minus 4x minus 32. And I'll hit graph. Again, use that standard window. And this one, when we go to graph it, it's a large graph, so we only see erase that part. I actually only see it go down, and then we see it come up here. Now it is a parabola, it's just so big it doesn't fit on the window all the way. We don't see the bottom of it. But my solutions will be -4 and 8. That's where it crosses over the x-axis. So here we're going to look at applications of quadratic equations. So sometimes when you see problems where you might need to solve a quadratic equation. And our first problem here is a number plus its square is 132. They want us to write the equation and solve it to find all the possible numbers to satisfy this statement. So we're going to start off with a number. I don't know what that number is, so I need something to represent it. So we're going to use x. So our number is going to be x plus, so a plus sign, its square. Well, if I have a number and I square it, it's going to make it x squared is an equal sign in math. So there's our equation. Now we have to solve it. Remember, all of our quadratics, when we solve them, have to be equal to 0. And they have to be written in descending order. So I'm going to start off and subtract 132 from both sides. And I'm going to write it in descending order. So I'm going to put the x squared first plus x minus 132 here. Now what I need to do, I can either use the quadratic equation or I can factor. This one, because it's an easy trinomial, I'm going to start with factoring and see if I can do that. And I know I'm going to have x, and a plus and a minus in that order, so I'll have 1 plus and 1 minus. And it's going to equal 0. Now for 132, I need to have a positive 1. So if you go through and list out your factors, you know, we obviously have 1 and 132. We could do 2 and 66. 132 and 3 divided by 3 is 3 and 44. Okay, but still haven't gotten to my factored part yet. Or a part that will give me a 1. I can do 132 divided by 4, which gives me 4 and 33. 5 will not go into it, but I know I can take 132 divided by 6. 6 and 22. Again, I'm not going to get a 1 using a positive and negative of any of these yet. Let's see here. I'm going to take 132. Let's see if 8 will work. Nope, 8 is not a whole number. 132 won't work with 9 or 10. Let's divide it by 11. And I get 11 and 12. So I need one positive, one negative. I need a positive 1, so my 12 will be positive, my 11 will be negative. That'll give me a negative 1, or a positive 1, excuse me. And now what I do is remember, we solved it by factoring, so I take each factor, and set it equal to 0. Oops. Fix that. And we will subtract 12 from both sides. So I get x equals negative 12, and here I add 11 to both sides. So I get x equals 11. So both, or all the numbers that satisfy the equation, are x can equal negative 12 and then also 11. So here we're looking for the product of two consecutive integers is 210. So we're going to write an equation and solve it to find all the possible numbers that satisfy this statement. Product of two consecutive integers. Product means to multiply. And consecutive integers, that is something like consecutive integers would be like 1 and 2. And that's just an example to kind of show you what we're talking about. Now, obviously, we don't know what ours are. So our first integer is going to be x times, I don't know what the next one is, but if I look at consecutive integers, like from 1 to 2, if I have 1 to get to 2, I add 1 to it. I have x, so I can't just say the next number is 2, but to get to the next number, it would be x plus 1, and then it's going to equal 210. So I'm going to start. To solve this, I have to make it equal to 0. And so I'm going to subtract 210 from both sides. And I'm going to have x times x plus 1. Oops. It's not equal to, but minus 210 equals 0. And then I do have to distribute. So it will be x squared plus x minus 210 equals 0. And again, this one looks like I'm going to try factoring first. If factoring won't work, then I'll use my quadratic formula. It's a plus and a minus, so my two signs are going to be 1 plus and 1 minus. And again, I need a positive 1 there. 210, I happen to know, I can sit here and list them all out. 1 and 210, it would be 5, and I want to say 45 would go into it. But I also know that 15 and 14 are two factors, and those, if I have a positive and a negative, will give me a positive 1. So I need a positive 15 here and a negative 14 there. And then I will make my two factors equal to 0. So we'll subtract 15 from both sides. So x equals negative 15. We'll add 14 to both sides. So x equals positive 14. So all the possible numbers that satisfy this statement are x equals negative 15 and 14. Now we're looking at the product of two consecutive odd integers. Now, odd integers, like if I just give you an example, consecutive ones would be something like 3 and 5. So the product, again, means to multiply. My first integer, if it is x, then, if x represented 3, to go from 3 to 5, we don't add 1 this time, but we add 2. And it would be that way if I did like 7 and 9, or any two consecutive odd integers. The first one is always going to be x. To get to the second one, you have to add 2. And it is 195. So again, we're going to do the same thing we did before. We're going to make it equal to 0. So we'll subtract 195 from both sides. And that's going to give me x times x plus 2 minus 195 equals 0. And then we're going to distribute. So we get x squared plus 2x minus 195 equals 0. And again, I'm going to factor this. So when we factor it, we need a 2x in the middle. And we're going to have a plus and a minus again. And if I look at my factors of 195, obviously 1 and 195, but that won't work. We could do 195 divided by 5, so 5 and 39, but that's not going to give me a 2. And then 5, 15 and 13. And that will give me a 2. I need a positive 2, so a positive 15 and a negative 13. And then set your factors to 0 and solve. So we have x plus 15 equals 0, and x minus 13 equals 0. So we'll subtract 15 from both sides. So x equals negative 15. We'll add 13 to both sides. So x equals a positive 13. And those are the two numbers that satisfy this equation. So we have negative 15 and positive 13. So here we're getting into a little bit of geometry with quadratics. And they give us a rectangle, and they tell us the dimensions are x plus 3 and x minus 2. And they want us to find the dimensions of the rectangle, the actual dimensions, not the two expressions, if the area is 84 centimeters. And if you recall, to find the area of a rectangle, you're going to do length times width. So when I plug in my values, I know that I'm going to have my length is x minus 2. My width is x plus 3. And it's going to equal my area of 84 centimeters. So now I have to go ahead. I can't solve it until I FOIL it. So then I'm going to FOIL and then factor. So it's going to give me x squared plus 3x minus 2x minus 6 equals 84. And when I simplify it, it'll be x squared plus x minus 6 equals 84. All right, now we need to make it equal to 0, so we'll subtract 84 from both sides. So that's going to give me x squared plus x minus 90 equals 0. All right, and when we factor it, 90, we have x, and we need a plus and a minus again. So I'll put my plus here, and my x minus here equals 0. 90, I need a positive 1, so I know with 90 we can do 9 and 10, because if I add them together, if I do a positive 10 plus a negative 9, that will give me a positive 1, which I need in the middle. And then again, set them both equal to 0. And so we subtract 10 from both sides on the first one, we get x equals negative 10. We add 9 to both sides on the second one, and we get x equals 9. Now, with a regular quadratic, we have two solutions. These are two real solutions. However, we're talking about the dimensions of a rectangle. If I use negative 10 in this problem, if I do negative 10 plus 3, it gives me a negative 7. Can you have a dimension that is a negative number, a length that is a negative number? You can't. So for this problem, even though the actual problem has two solutions, the negative 10 we can't use because it would give me a negative distance, and we aren't allowed to have that. So my answer is x equals 9, but then what we have to do is find the length of each side. So we'll plug it in. We'll do 9 plus 3, and we get 12. And then here we do 9 minus 2, which gives me 7. So my two dimensions are 7 and 12. All right, here we're going to find the dimensions of the triangle if the perimeter is 112. And remember, with perimeter, that means you're going to add up all the sides together. So I'm going to start up and add all my sides together. I will do x squared plus 4x minus 7 plus 3x minus 1. And that's going to equal my perimeter of 112. So I'm going to add them all together, combine like terms. So I have x squared plus 7x minus 8 equals 112. But again, to solve it, I need to make it equal to 0. So I am going to subtract 112 from both sides. 112. So that leaves me with x squared plus 7x minus 120 equals 0. And I need to, when I factor this, I'm going to need a plus and a minus. It's going to be equal to 0. And I need to make 120, and it also needs to add to 7x. I know that with 120, we can use 15 and 8. So it'll be a positive 15 and a negative 8. So then again, I'm going to make them equal to 0. So x plus 15 equals 0, and x minus 8 equals 0. I'll subtract 15 from both sides. So I get x equals negative 15. I will add 8 to both sides here. So x equals 8. Now again, we're talking about dimensions. So when I look at this, I have a negative and a positive answer. They're both answers to the quadratic, but we aren't going to use the negative number because we can't have negative distances. We're going to use the positive 8 for our answer. That's the one that we can use. So then we're going to find the length of each side. So 8 squared, or x squared, would give us 64. Then we're going to do 4 times 8 minus 7, and that is going to give me 25, because 32 minus 7 is 25. And then we'll do 3 times 8 minus 1, so we get 23 there. And if you check it, if you add 23, 25, and 64, they should add up to 112, and they do. So here we're talking about the width of a rectangular painting, and it's 9 inches longer than its length, and the total area is 112 inches. So we want to find the dimensions of the painting. What we're going to do is the width of the painting is 9 inches longer than its length. Well, we don't know what the length is, so I'm going to call that x. That's the length. And the width is 9 inches longer than the length. So 9 plus x will give me my width. And we know the total area is 112 inches. We have an area is length times width. So we're going to do x times 9 plus x equals 112. And we'll go ahead and distribute. So we'll get 9x plus x squared equals 112. Then we'll subtract 112 from both sides. And I'm going to put it in descending order. So I'm going to have x squared plus 9x minus 112 is equal to 0. And we need to factor this. So when we factor it, we're going to have, again, a plus and a minus. And we'll look at our factors of 112. It needs to add to 9x. So, again, I know 1 and 112 would work. 2 and 66 would work, but there are factors of 112, but they don't work with 9. But 16 and 7 do. So I'll add 16 and subtract 7. And again, I just got that by going through my factors. You can use your calculator, start dividing by like 2, 3, 4. All right, then we'll solve it. Set them both equal to 0. So here we'll subtract 16 from both sides. And I get x equals negative 16. Here we'll add 7 to both sides. So I get x equals 7. But again, in the context of the problem, we're looking for dimensions. Can't have a negative dimension, so 7 will be the number we use. So the length is going to be equal to 7. And the width is 9 plus 7, which is 16. So my dimensions are going to be 16 and 7. So now here we have another problem, and it's multi-step. We have a rock that is dropped off a 400-foot cliff. The height of the rock from the bottom of the cliff is represented by the quadratic equation. H equals negative 16t squared plus 400. And there's our equation, where t is the time in seconds. So first they want us to find the height after 3.4 seconds. So t represents the number of seconds. For this first part, all we have to do is plug in 3.4 seconds into the equation and solve it. So to find the height, we're going to do h equals negative 16 times 3.4 squared plus 400. Order of operations says I need to do my 3.4 squared first. And I get 11 and 56 hundredths, which then I will multiply times a negative 16. So I get negative 184.96, and we'll add 400 to that. And that's going to give me 215 and 400ths, and that will be the height of the rock after it's dropped off the cliff, or after 3.4 seconds when it's dropped off the cliff. So, and it's 400-foot cliff, so it's 400 or 215 and 400ths feet above the ground. So for B, they want us to find out when does the rock hit the ground. So we're going to start off, and when it hits the ground, the height of the rock would be 0 because it's on the ground. So instead of h equals, we're going to do 0 equals our equation of negative 16t squared plus 400. And I'm going to start and see if I can factor this. I'm going to take 400, and I just want to see, can 16 does go into it 25 times. So, and because this is a negative 16, we're going to start and we're going to factor out a negative 16. So we're going to have 0 equals, and then we'll do negative 16 equals, and it's going to give us a positive t squared, but then 400, positive 400 divided by negative 16 will give us a negative 25. So now we have negative 16 times t squared minus 25. And if you notice, since we factored out the negative 16, this expression right here is my difference of perfect squares. So I can factor that further. I'll make it 0 equals negative 16. And then remember, you're going to do t plus 5 times t minus 5. And then we'll take our factors and set them to 0. Now, when we do negative 16, you have 0 equals negative 16. That's not true, so really we can't do anything with that. We don't worry about it. We're going to take care of the t plus 5 equals 0 and t minus 5 equals 0. So we'll subtract 5 from both sides here, and then we'll add 5 to both sides here. And that's going to leave me with t is equal to negative 5 and positive 5. But we're looking for a time. We want to know when the rock hits the ground. It's not going to hit the ground at negative 5 seconds. It's going to hit the ground at 5 seconds. So we're going to use the 5, the positive 5. Negative 5 actually represents when you dropped the rock. So at 5 seconds, it will be on the ground. And then our last one, C, says how long does it take so that the rock is 200 feet from the bottom? So now our height is equal to 200. So we're going to plug it into our equation, and we're going to do 200 is equal to negative 16 t squared plus 400. We have to make it equal to 0, so I'm going to subtract 200 from both sides. And that will give me 0 equals negative 16 t squared plus 200. Let's see, negative or 200 divided by 16. Does it go in? It goes in 12.5 times, so that won't work. I do know that I think I can factor out an 8. 200 divided by 8 is 25. So let's factor out, and let's do a negative 8. So I'm going to factor out a negative 8. So that will leave me with 2t squared minus 25, which it would be really nice if we could factor this expression, but it is not two perfect squares because 2 is not a perfect square. So what we're going to do is we are going to use our quadratic formula. We don't have to worry about the negative 8 because that's on the outside. Our 2 is going to be our A. Our B is actually going to be equal to 0 because we don't have an x or a t term. And C will be 25. So we'll say that H equals 0 plus or minus, and then we're going to have the square root of 0 squared, which is 0, minus 4 times 2 times negative 25, all over 2 times 2. So we'll have H equals 0 plus or minus the square root of negative 4 times 2 is 8. Negative 8 times negative 25 will give me 200. So 2, and divided by 4. So really, we are going to solve, we're going to do the positive and negative root of 200, square root of 200, and divide it by 4, which this is definitely a calculator problem to do. The square root of 200 is, and I'm going to round it, but 14.142, and we'll divide that by 4. I'm going to look for the positive and negative root. So 14.142 divided by 4 is going to equal either a positive 3.5355 or negative 3.5355. But again, we're talking about time and distance. So at roughly 3.5 seconds, the rock will be 200 feet from the bottom. So we want the positive answer there. Okay, here is our last question on the applications. And we are looking for A, the height after 1 and 3 seconds. And this time we have an object being thrown upward from the top of an 80-meter building with an initial velocity of 64 meters per second. The height of the object after t seconds is given by h equals negative 16 t squared plus 64t plus 80. So we're going to start with A, and we will find the height after 1 second. So we're going to plug in 1 for our time. And when I do the math there, I'm going to have negative 16 plus 64 plus 80. And that is going to give me 128. So it'll be 128 feet. And then we're going to plug in 3 as well. So we'll do negative 16 times 3 squared plus 64 times 3 plus 80. So we'll do negative 16 times 9 because 3 squared is 9. So I get 144, negative 144, plus 64 times 3 plus 192 plus 80. So when I add it all together, we get 128 feet. Now, it says, how is this possible? How can they be the same? But I want you to think, we're throwing the object upward. When you throw an object upward, it doesn't just go straight up and come down. It goes up in a parabola shape or a U shape like our graphs looked at. So 1 second and 3 seconds, this is when at 1 second it's going up, 3 seconds it's when it's coming down, but they're at the same height. So for B, we want to find when the object hits the ground. So we're going to plug in, we're going to make our H 0. Because again, the height is 0. And it's going to equal negative 16 t squared plus 64t plus 80. And this is one where we can pull out a negative 16 and then factor it. But if you didn't see that, you could always pull out a GCF and then use your quadratic formula. So I'm going to factor out a negative 16. And that will leave me with t squared minus 4t minus 5. And we'll factor that as we'll do t. We're going to have 1 plus and 1 minus. And my 2 are going to be a minus 5 and a plus 1. So we'll excuse me, we'll set those to 0. So t plus 1 equals 0, and t minus 5 equals 0. So we'll subtract 1 here. We'll get t equals negative 1. We'll add 5 here. So we get t equals positive 5. And again, we're looking for positive values time. So we're going to use the t equals 5. It'll hit the ground at 5 seconds. So the last thing we're going to do is find out how long it takes for the object to be 36 meters from the bottom. So 36 meters is a height of the object. So when we plug it in to our equation, we're going to start off and plug it in as our answer. So we're going to have 36 equals negative 16 t squared plus 64t plus 80. We'll make it equal to 0, so we'll subtract 36 from both sides, which leaves me with 0 equals negative 16 t squared plus 64t plus 44. And I'm going to rewrite this equation on the next page to solve it so we have more space. Okay, so our equation that we are solving again is 0 equals negative 16 t squared plus 64t plus 44. And, again, it looks like a hard one to factor. I do see, if I look at this, that I think there's a common factor of 4. So I'm going to pull out, because it's 16 is negative, our leading term is negative, I'm going to pull out a negative 4 out of our factor, our expression. So we'll do negative 4, and then it's going to be equal to 4 t squared plus 6, or excuse me, not plus, but minus 16t minus 11. And from there, now it's going to still be pretty hard to factor, and I don't even think it's factorable. So I'm going to go ahead and use our quadratic formula. So here's my A, my B, and my C. So we'll have t equals the opposite of b, so it's going to be 16 this time, plus or minus the square root of 16 squared is 256 minus 4 times 4 times negative 11 all over 2 times 4. So we get t equals 16 plus or minus the square root of 256 minus 4. Negative 4 times 4 will give me negative 16. Negative 16 times 11 will give me 176. And it's going to turn it into a positive. Those 2 negatives make that a positive. All over 8. And that is going to be t is equal to 16 plus or minus the square root of, and we add it together, you get 432 divided by 8. So this is definitely one for the calculator. It's not a perfect square, the square root of 432. So we're going to do 16 plus the square root of 432 divided by 8. And then also 16 minus the square root of 432 divided by 8. And when we do that on our calculator, 16 plus the square root of 432 divided by 8 is going to be approximately, I get 4.598, so I'm going to make it 4.6. And it goes on, but and then the negative 16 minus the square root of 432 is going to give me negative 0.6. So again, when we're looking for our answer, we're looking for a distance. We're not going to deal with the negative distance, so we want the positive distance. So 4.6, and this is actually seconds. So 4.6 seconds.